Okay, moving on to Chapter 10, Complex Experiments. So we're building on from the framework we had in our last lecture of basic experiments. So at the end of today's lecture, I'd like for you to be able to define a factorial design and discuss the reasons why a researcher would use this design. I'd like for you to be able to describe the information provided by main effects and interaction effects in a factorial design, and describe the features of something we call an independent variable by participant variable, or PV design. So we talked about non-experimental research first, and then we moved on into experimental research, where we focused on the fact that all extraneous variables are controlled. And remember, in our last lecture, we used the example of crowding and its effects on cognitive performance. And we had two levels of that independent variable. One was little or no crowding, and then a lot of crowding. And in simple experiments, as we discussed in the last lecture, there are only two levels of the independent variable. But what if I wanted to look at three or more levels of an independent variable? So let's say I wanted to look at very little crowding, moderate crowding, and then big time crowding. So that's three levels of an independent variable. Well, if I wanted to do that, I would need to design what is called a complex experiment. And the key feature of a complex experiment is that you're going to get a lot more information. So with a basic experimental design that only has two levels of the independent variable, you're not going to be able to be provided with very much information about the exact relationship between the independent variable and the dependent variable. So let's look at an example, and let's look at a different example. Let's say we were interested in looking at the relationship between increases in salary and someone's job performance, or individual's job performance. And let's say that we graphed it, and we had two levels of an independent variable here, as in our basic experiment, and one level was no salary increase and the other was a 4% salary increase. So when there are only two levels, no salary increase and 4% increase, there's only one way to describe that relationship, and that's with a straight line. So we don't know what the relationship would be if there were other amounts of the independent variable, or increased numbers of levels of the independent variable. So let's go ahead and move that up into a complex experiment, and say that we might be interested in adding other levels of the independent variable. What happens is the relationship between the independent variable and the dependent variable gets more accurate. So an experiment with only two levels of the independent variable, as illustrated by the straight line here, can't detect this curvilinear relationship that you see here. So researchers are often interested in manipulating more than one independent variable in a single experiment, okay? More than just one level, but also more than one independent variable. So let's say, using our same example, that we were interested in looking at the effects of crowding on cognitive performance, but also windows, okay? And we have, again, little crowding and more than a little bit of crowding. And then we add a second independent variable, no windows and windows. When we use multiple independent variables, it mimics or is more like real-world conditions. So we could look at the effects of crowding and the effects of windows on performance at the exact same time. So whenever you have a design with more than one independent variable, and another way of looking at an independent variable is simply to call it a factor, we have what's called a factorial design. And in a factorial design, all levels of each of the independent variables are combined with all levels of the other independent variables. So the simplest factorial design is what is called a 2 by 2. The first number here tells us that there are two independent variables, and the second one tells us that there are two levels of that independent variable. So, for example, we have two independent variables that I just described. One independent variable was crowding and the other was windows. and each of them has two levels. Crowding was no crowding, and windows was no windows and windows. Here's an example from real research of a 2x2 factorial design. An experiment was conducted by Smith and Ellsworth in 1987, and they were interested in studying the effects of asking misleading questions on the accuracy of eyewitness testimony. So here is the person in the experiment, and this person would ask misleading questions to see how accurate their testimony was. So the participants in this experiment, they would view a robbery, and then they were asked questions about what they saw. So one independent variable was the type of questions they were asked, and the levels of the independent variable where they were asked either misleading questions or not misleading questions, or what are called unbiased. The second independent variable was the questioner's knowledge of the crime. So in one level of the independent variable, the questioner had a lot of knowledge of the crime. So they viewed the videotape several times before they asked questions. In the not knowledgeable situation, the questioner had only viewed the videotape once. So what you can infer from here is that the knowledgeable questioner could ask more misleading questions because they had viewed the videotape several times. So with the factorial design, you multiply the number that you have, the number of independent variables times the number of levels, and that tells you how many experimental conditions you have. So a 2x2 factorial design results in 4 experimental conditions, as you see here. So you have a knowledgeable questioner that asks misleading and unbiased questions, and then a naive questioner who only viewed the tape once, who again asks misleading and unbiased questions. So the general format of any factorial design, as I said earlier, is a number of levels of the first independent variable times a number of levels of the second independent variable times a number of levels of the third independent variable. So, and by the way, I might have been a little bit misleading there. So the first number, again, any of the numbers just tell you how many levels of the independent variable you have, and any number that's there, as I have here, simply tells you that this is an independent variable, my apologies, and this is an independent variable. So the number just tells you the number of levels. So if this was a 3x2 factorial design, this tells you, the 3 tells you that there's one independent variable with 3 levels, and the 2 would tell you that this is another independent variable with 2 levels. Sorry for any confusion there. So again, the number of levels of the first independent variable times the number of levels of the second independent variable times the number of levels of the third independent variable. So let's talk about how we interpret factorial designs. Any factorial design gives you 2 kinds of information. The first type of information is what we call the main effect, and this is simply the effect of any one independent variable on the dependent variable, irregardless of the other independent variables. And interaction effects, the second type of information that you can get from a factorial design, is the effect of one independent variable taking into consideration its relationship with the other independent variables. So let's use the eyewitness example again, in which they were interested in looking at the effects of asking misleading questions on the accuracy of eyewitness testimony. And here are the results. You see here that on this axis we're looking at the questioner type, whether or not the questioner was knowledgeable versus naive, and this is the overall effect of the questioner type, knowledgeable or naive, over here on main effect B. And then over here you see the type of question, whether or not they were asking misleading versus unbiased, and in blue here are the overall or main effect of A. Let's dig into that a little bit more. So again, main effects are the effects of each variable by itself. So the main effect of independent variable A, which was the type of question, is the overall effect on the dependent variable, which is the number of errors that someone would make. So the question that we want to ask with main effects is there a relationship between the type of question that we ask and recall errors? Well, let's take a look. Okay, so we look at the overall means in the unbiased and the misleading questions for type of question. And what we see is the means are the average across all participants regardless of this other variable. So let's pretend like this doesn't even exist for main effects. And overall what we see is that there are more errors that are made when the questions are misleading than when they are unbiased. And recall that the main effect again is the effect of each variable by itself. So the main effect of the independent variable, the type of questioner, for the second one is the overall effect on the dependent variable regardless of the other variable, which was misleading versus unmisleading or unbiased. So the question that we're asking here is there a relationship between the type of questioner, knowledgeable versus not knowledgeable, and recall errors? So to find out, we look at the overall means in the other variable, variable B, which is knowledgeable versus naive. And again, the means are the average across all participants regardless of the other independent variable A. And again, overall, more errors are made when the questioner is knowledgeable than when the questioner is naive. So we have a good understanding, hopefully, of main effect, which again is the effect of any one independent variable irregardless of the other variable. But what about interaction effects? So using our same eyewitness example, we have two types of variables. One is a type of question, and the other is the type of questioner. So if we want to look at interaction effects and its relationship on the accuracy of eyewitness testimony, we need to look at interaction effects. So the main effects told us that overall more errors were made when the questions were misleading than when they were unbiased, and for the other variable, that overall more errors were made when the questioner was knowledgeable than when the questioner was naive. But what if there is an interaction between these two variables? In other words, what if the relationship of one of these variables depends upon its relationship to the other? So an interaction between independent variables indicates that the effect of one independent variable is different at different levels of the other independent variable. In other words, like all good psychologists, we're able to say that the effects of one independent variable depend upon the level of the other. I swear this is a tongue twister. So, and in fact, when you look at the interaction effects for this experiment, that's exactly what you see. So you can see an interaction here. The effect of the type of question is different depending upon whether the questioner is knowledgeable or naive. And what we see here is that when the questioner is knowledgeable, and remember that was when the questioner was able to look at the video several times, misleading questions lead to more errors, as you see here. When the questioner knowledge is not an issue, as you see over here, it's not an issue when the unbiased questions are asked. So the bottom line is we need to look at whether the questions are misleading and whether the questioner is knowledgeable or naive. So moving on to the last part of our discussion, we're going to look at something called IV by PV designs. And this stands for independent variable by participant variable. And this is a common type of factorial design that includes both experimental, things that we can manipulate, and non-experimental, or variables that are measured or non-manipulated variables. And the unique thing about an IV by PV design is it allows researchers to investigate how different types of individuals respond to the same manipulated variable. And this is good because we can't manipulate some types of participant characteristics. So participant variables that we can't manipulate that we're often interested in looking at in these types of designs include the following. Things like gender, age, ethnicity, personality characteristics, or, for example, clinical diagnostic categories. So the simplest IV by PV design has one independent variable that we can manipulate and at least one participant variable, and again, something that we can't manipulate. And so examples might be 2 age groups or 2 personality types. So here's an example of a PV by IV design. Fernham, Gunter, and Peterson examined the relationship between distraction and personality on reading comprehension. So in other words, they were interested in finding out whether or not you could study while you were being distracted, for example, by watching TV. So what they found was that the ability to study with distraction depended upon whether or not you were more extroverted or introverted. And so that was the participant variable, whether or not you were introverted or extroverted, because again, you can't manipulate that. So what they did, here was a setup. They asked college students to read material in silence and then within hearing range of a TV drama. So maybe it was Law and Order. So you could you would be asked to read material and then to do it again in front of a TV drama like Law and Order. Dun 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 dun. So they would hear that. And since the students were being asked to listen to the material or read the material in silence first, and then also within hearing range of the dun 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 TV drama, it is a repeated measures design because they're being exposed to all levels of the independent variable. And after they read, they completed a reading comprehension measure. But they also completed a measure of extroversion that would classify them as either an extrovert or an introvert. So the manipulated variable was the distraction, whether or not they were in silence or whether or not they were watching Law and Order, dun 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 dun. The participant variable, the one that you can't manipulate, was extroversion versus introversion. And overall, what they found was that students had higher comprehension scores when they studied in silence. Okay, so the bottom line, guys, whether you're introverted or extroverted, it's better to study in silence. But there was also an interaction. So without the distraction, the performance of extroverts, okay, and introverts was almost the same. But with the distraction, interestingly enough, the extroverts kicked the introverts' butts. So they did better on that reading comprehension. You're going to have an activity. If you're in the face-to-face class, we're going to do this activity in class. But if you are in the online class, I will present the information to you and also give you the key, but it's also something that I really think is very important to helping you to flesh out these issues with factorial designs, really understand what the independent variables and the dependent variables are in these studies, and also repeated measures designs. So that's the end of Chapter 10. Hope you learned something. Sorry for any confusion earlier with the factorial designs, but I'm sure that you guys have it, and if not, don't hesitate to ask me questions. Thanks, and take care.